So this will be your largest assignment of the year, longest assignment. A giant two-part review on linear systems, which I'm going to probably give a whole lot of points to on this work standard. So I've broken this video or this assignment into two different videos, but it is very big. You also have some linear system type notes that you might want to refer to. So we will get started. I'm only going to do one on each section, so that and sometimes three, based on the type of solutions. Linear systems, things that you did in Algebra 1, need to be reviewed, both from solving and from a word problem perspective. And I'm going to say on the word problems, which is the second part of this, you can focus on the setup and then use technology to solve it. So solving by graphing, essentially what you're going to do is you are going to graph with a straight edge, I might add, with a straight edge. So I had to pause and go find mine. And then you're going to find the point of intersection and then just double check it back into both equations. So when y is solved for, it is the absolute easiest. You're going to use something called, if it works well, the slope-intercept technique. So you're going to start with the y-intercept at -3 and then do 5/3 up 5 and right 3 to get your other point and draw the line. And so these will have a pretty nice, I started you off with pretty easy problems. And then the second equation, y-intercept is 3, and then down 1 and right 3. So you're going to get a point of intersection that are they're nice integer coordinates right on the lattice points. Pretty cool stuff. 3, 2. And you can check that in. That makes true statement in both. Okay, so that you're working along and working along. Some of these have horizontal and vertical lines. I suppose I could do one of those. Problem 12 we'll do next. So I'm going to be flipping through lots of pages here. So problem 12. So y equals 4, what does that mean? That just means a horizontal line through 4. All the y coordinates are 4. You can think of it that way. So you can plot a bunch of points where the y coordinate is 4. And then just do the slope-intercept of the second equation. So -2 is the intercept, and then the slope is 6. 4, 5, 6, and right 1. So the point of intersection looks like 1, 4. Let's draw the line now. You're going to have other types of systems, other types of solving. Okay, and let's go through this. Okay, so this section, when you have equations in standard form, I'm going to tell you, and we'll do one of each here, like a no solution, and all reals, and one where you get an answer. That you need to solve for y, and after doing that, you can probably, figure out pretty easy without even graphing what the deal is. So on the top equation, solving for y, we're going to take the 3x to the other side. The reason I say that is that you can compare the slopes pretty easily. You can compare the y-intercepts and the slopes. So you have 5 that'll be no solution, meaning the same slope but different y-intercepts. 4 infinite numbers, meaning that they're identical equations. And then 3 where you actually get an answer. But you need to solve for y first. And so that involves the manipulation of terms and dividing. So divide by -10, so this will be -3/5. And then 14 over -10, you can reduce that to -7/5. You need to do that first. So you have the same slope, meaning parallel lines, but different y-intercepts. So this is a no solution case. So you can think about it without even graphing that you have different y-intercepts, but you're doing the same rise over run, or down 3 and right 5. So the lines are going to look like this. But if you just want to solve for y and do an analysis, you can avoid the graphing. So there is a no solution. Let me do an infinite number of solutions, like problem 3. So again, we want to take this and solve for y. Remember that, as you move terms, okay, it changes the sign as you move from one side to the other. So 6y would equal negative 14x, and then divide by 6. So this would be negative 7/3 x, also when you reduce. That's an identical set of equations, meaning that this is an infinite number of solutions. Let's do one where there's actually a solution. And you can kind of tell problem 7 by looking. You can look at problem 7 and say, oh man, that's just going to have a completely different set of solutions. So what I would recommend is solving for y, putting it on your table, and getting points from there. So negative x plus 1. So this is going to be 1/8 x minus 1/8. Got to know how to solve for y. It's very, very important. And then the second one, and then divide by negative 6, so negative 1/2 x plus 1/2. So those have different slopes, meaning that you're going to have a solution. And you might want to put them both on here at the same time. I'll actually show you how you can look. And of course, there's the PolySimult app, which actually solves them. So you can look, let's just reset the table here, 0 by 1, and then go to your table. Wherever, so 1, 0 is the point of intersection. So if you see it, the same y values twice like that, that's the point of intersection. So 1, 0 is part of both graphs, and you can just get a different set of points. So 1/2 negative, or 5 1/2 for one graph. So you got to use the x coordinate with each y, and then that goes through. And then 5 negative 2. So this is what the two lines will look like. Now don't forget, I will allow you on most of this to actually go and use the app. So I'm going to say, on a couple problems, show your work. And then I don't care if you go and use either app, the online one or the PolySimult. But remember, if you're going to use the PolySimult, that you need to have the equations stacked, which they actually are in this case. And then you're just going to put in the values 1, negative 8. Oops, this doggone thing. Gonna drive me crazy. They literally planned this. Oh, the app is free during the pandemic. Now somehow they mined my data and they're advertising like crazy. Okay, so solve 1, 0. There it is. Okay, so 1 each on this, and that takes us into the next. So I don't care how much you use the app, but show your work on at least 1 in each of these sections. So I'm going to show these 3 on this section, solving by substituting. So if you have one variable solved for, generally you can substitute that into the second equation for that variable. So what is meant by that? So the negative 3x plus 5 goes in for the y in the second equation. And then just work it through. Minus 20. So 17x minus 20. Add 20. So x is 1, and then you got to go back and substitute into either one. I'm going to pick the top one. Negative 3 times 1 plus 5 would be 2. Remember, your answer is either a coordinate, infinite number of solutions, or no solution. Okay, the giveaway for substitution is one of the variables is solved for in one of the equations. So 18x minus 3 times 6x minus 11. Everything else stays the same. You just put in, you throw the y out in the second equation and you put 6x minus 11. And then you work this through. This probably would not be, it's probably easier to do this by hand than use the app because the systems are all mixed around. So we have an infinite number of solutions because the variables drop out and you have an identity. And now on this one, the variables are going to drop out, but you have something that's not true. So n for y is going to go x plus 5. And then everything else stays the same, and then just work it through. So you get negative 10 equals negative 1. That's a no solution. Okay, so that brings us to the method of elimination. Again, I want you to show your work on a couple of them, 2 or 3, and then you may use the app to get the answer, either the online app or the calculator app. But you need to know how these work by hand so that you can at least show the work if you have to show the work. So these 3 are each one solution, a no solution, infinite numbers. So this is just giving you the total throughout the whole section. So what you have to do is you have to try to create opposites on one of the variables. And a way to do this is just to multiply the other row. So bring the 4 up here and the 3 down, but make one of them negative, and just run that through the whole way. Make sure you run it through. And then 26 times 3 is 78. And so as you multiply both of those rows, when you add, you'll get one of the variables to drop out. So this is 114. And so when you divide by 38, you get 3. So 3 then needs to go into one of these. If we put it into the top one, that's 15, negative 15, add 15, so that's 6. So 3x would be 6, and then x would be 2. You can show your work a little bit more than that, but I'm in a little bit of a hurry to get through with this, so the video is not too long with this. So that one had a solution. On this next one, if I multiply the top row by 2, both the x's and the y's drop out. We get a 0 and then a 39. So when that happens and the result is false, it's a no solution. And then on 3, if you multiply the bottom row by, say, let's multiply by 2, or negative 2 rather, everything drops out. So this got multiplied by negative 2, this got multiplied by 2. Let's show my work here. Everything drops out. And when that happens, we have an infinite number of solutions. Just to make a comment, so what is that all about on the Polysimul app when it puts, let's run this through the Polysimul. I want to show you. So if it, someone asked you the collegiate level, tell me, if you say infinite number of solutions, what type? So you could do this. Y is any number, and then x equals 4 plus y. That's what that means right here. So the x2 equals x2 means that's the calculator's way of saying y is any number, and then x is 4 plus that. Those will be solutions to that system. That's what that's about. All right, so the any method one is you decide. So I'm going to do 1 and 2, and then let me find an all reals here, and 6. 1, 2, and 6 on this. So you see how y is solved for in both? This is going to be the method of substitution where you set them equal to each other. So basically you're substituting for y twice, and then the 7x's drop out. That's a false statement, so we have a no solution. Number 2, if we multiply the bottom row by 4, we'll get the x's to drop out. This is pretty easy work in the end. You also have the app. I just don't want you to forget about all of this. So add it, and y is 5. And then x, go back up. And so 9 times 5 is 45. 9 minus 45 is negative 36. So 9, 5 is that solution. Again, check your work with the app, that's for sure. And then the last one here on this half, number 6. So you don't have to do anything but add. You get 0 equals 0, so this is an infinite number of solutions. Again, how can we represent that? And actually, there's work that you can do with this too, but I don't want to get into it and throw too much at you. Just solving one of the variables for the other, that's what's going on. So y is any number, and then x is negative 11 halves plus 3 halves times y. So if you needed to tell me, how are the answers going to be? This just comes about, however, you could say x is any number, and then you would solve for a y, or you could say y is any number, then you solve for x on either one. So that's what is happening. Maybe I can look at the previous one with that. Yeah, because this is pretty easy. So all that happens is so you say y is any number, then solve for x, so you just do y plus 4. That's all that's going on with that. You could do it the other way. Say x is any number, then solve for y. Y would be x minus 4. So that's all that's happening with that. So you have the rest to finish. Use the app on as many as you want. I just don't want you to forget about linear systems and the 3 possibilities.